let us proceed with the session. 3D modeling of a pitched roof warehouse. Okay, so this is the architectural drawing which we are going to study. Let me show you the drawing. This is the drawing. We had a view yesterday. The section view is important right now. Let me show you that. Yes. You can see from ground level at 0.6 meter you have the plinth level, and from 0.6 level to 5.5 meter, this is your height of your warehouse. So your steel structure will start from this level 0.6 and above. So this whole part is your steel structure. This we are going to model in STAAD.PRO. Let me open STAAD.PRO. Okay, if some people are not able to attend the recordings, they are not able to see the recordings, then you have to contact with the management team. They will help you out. Suraksha is telling he is not able to contact, he is not able to see the recordings. Then you can connect with the management team, they will help you out. Okay, let's start the new model. I'll click on new 3D pitched warehouse. Pitched roof warehouse. Choose the location where you want to save it. This is the file where I'll save it. Okay. Create a model. This is the blank file which will open. Before starting the modeling, let us understand what we want to model. Now, what is pitched warehouse? The meaning of pitched. Any warehouse, any structure which is having slope on two sides. This is called a pitched roof warehouse. Simple definition. A structure which is having slope on two sides is called pitched roof warehouse. Okay, so for modeling purpose, I have a small Excel which will help you in understanding the dimensions. Let's open that. What are the geometric parameters? These data you should get from your architectural drawing. Let's see the length of the warehouse. If you go in the model, the length of the warehouse is 26.5 meter. So here I have written 26.5 meter. Width of the warehouse 19.7 meter. Width of the warehouse is 19.7. Height of the warehouse we have seen. In section you can see height from the steel part, where your steel part would be starting. This would be your base plate of your column. So above this you have to consider this is 5.5 meter. And height of the roof. Height of the roof is not given. This you have to decide. So generally we try to take the height of the roof in such a way that the angle, slope angle is around 10 degree, more than 10 degree. So I have taken 2 meter as the height of the roof. Then my angle is 10 degree. This I can also take as 1.5. This is also okay. 8.6 degree is good enough. So generally, let's take 2 meter for now. Okay, this would be your height of the roof. So this is the main part. What we have seen from the yellow part, we have seen from the architectural drawing. Now you have to decide the number of bays in Z direction and the number of bays in X direction in such a way that the column spacing in X direction and column spacing in Z direction, this is near around 4 meter or 3 meter, 4 meter, 5 meter, like these values. So I have taken 6 and 4 such that the column spacing is around 5 meters, 4.9 and 4.42. And Perlin spacing I have written over here 1.675. So let's see. Let's start by modeling this. Starting with point number, let's click on geometry, point number 0. Next point will be at a height of 5.5 meters. So y will be 5.5 meter. And next will be at a distance of 5.5 plus 2, that is 7.5 meter. But this value will be half of the width. So now width is 19.7. So half of this, because the center line 9.9, 9.85. So this I will write 9.85. Okay, so let's connect them first. This is my column, this is my rafter. Okay, if I see this from front, this is the view. Choose them. Now I'm showing you some other methods in which you can model. Now I want this same part on the other side, so I can just mirror this. So if you want to mirror it, go in geometry. Here you have various options. One of the option is mirror. Click on mirror. When you click on mirror, this window will appear. You have to choose your mirror plane. Mirror plane is YZ plane. This is my mirror plane. To choose that plane, and if you want to choose the point where you want to do the mirror plane position, click on this and choose this point. When you choose this point, some values will get edited over here, and you want to create a copy. That's why click copy and click OK. In this way, a mirror image has been created. So this is my section view of my warehouse. Now if you view this from 3D isometric view, so this is my warehouse. Now what I want, the next thing, I want number of bay in Z direction. If you see number of bay in Z direction, I have taken as 6. So I want to copy this frame 6 times, and spacing which will between each frame should be Z 4.42 meter. So how I will do that? I will choose this, Control A, and choose all these things. Again go in geometry. The second option which I will be using is translation repeat. Translation repeat. If you click this, number of copies of the same model what you have modeled, that will be created. I want to copy them in Z direction, so I will choose Z. The spacing is 4.42. This I got from my Excel, and the number of steps is 6. So 6 times I want to copy, and between each copy the spacing should be 4.42. Here I have few options. Link steps. Do I want to connect them? You can choose from here. Right now I want to connect them, so I'll choose link steps. And base I want open, so I will click on open base, and I will just click OK. When I click OK, you can see a copy of them is created 6 times, and all the nodes are connected, but the bottom node is open. So because I had chosen open bay, so this is also done. Next thing, I want to model the purlins. No, before modeling purlins, I want to model the columns in this direction, the other direction. So here if you see, number of bay in X direction is 4. And the number of bay in z direction was 6. So let us count in z direction first. 1, 2, 3, 4, 5, 6. Similarly, in x direction, I want 4. Right now, it is only 1. I want one column in the center, so it will become 2. And again, one columns over here. So let's start modeling that part. Let me think, how should I model it? Yeah, I will just simply choose them and control copy paste. I will just copy paste these two at a distance of x direction 9.85. When I click OK, they will come over here. Okay. So again, one I want in the center of them, and this I want to connect till top. One option I have, move nodes. If you click on move nodes. Let's see. No, this is different. Move origin. Yeah, I will try another method. Let me think. Geometry, add beam. I will just add beams over here like this. I have connected them at the top. Now what I want to remove this additional node which I have created. So just click over them, click these members, go in beam tool, merge beams. So these two beams I will just merge. So when I merge, it's done. Now I want one more member at these points. So I'll choose these four beams, rafters, beams, insert node, distance is proportional, new point by proportion. So I want point at the center, or I can choose add midpoint and click OK. So one midpoint is created at this location. So I'll just choose these two members. Again, go in geometry, copy, paste, reference point. In reference point, I will choose this top point. When I choose this top point, click OK. Then I'll copy one over here like this. I'll copy other here and then click enter. Okay, so this also I have copied. Now I'll press escape. But you can see this is slightly longer. I want to cut this long part. So I have another method, add beam from here to here, from here to the other end. And this additional part I will just cut it out. So for that I will choose these, press Ctrl button and choose these members where I want to cut it out. Then go in beam tool, intersect beam. Okay. So wherever the beam is intersecting, there a node would be created. I will go in view, front view. I can easily choose them and I can just delete them. Similarly, I will also delete this bottom members because I don't want them right now. Delete. Okay, let's view this. Display whole structure. The whole structure would be visible to me. Yes, this looks good. I have modeled all the columns. I have modeled all the rafters. Now I want to model all the purlins. So to model the purlins, if I double click on this member, you can see the length of the member is 5.0225. Okay, so 2.5 and 1.25. I will divide this phi into four parts. Okay, so I will first what let's do one thing. Add beam. I will add these rafters, so it will become simpler. Okay, once I add these rafters, I'll go in utilities. No, control A. I'll choose all, beam tool, intersect beam. Okay, so after drawing that, so at all these points a node is created. So now it is easier for me if I want to divide this rafter. I will divide this rafter into, let's divide it into how many parts? 5 meters. So only uh, general understanding is the spacing between purlins should be between 1 to 2 meters. So if I want something between 1 to 2 meters, 5 meters, I can divide this into 3 parts. So yes, let's divide all the purlins into all the rafters into 3 parts. So I'll choose them 1, 2, 3. Or first let me do the one, then I will understand if it's okay. Right click, insert node. If I right click on any member and click on insert node, this will come to me. I want 3 number of nodes. So add new points, add endpoints, sorry, add endpoints. So 1.25, 2.5, 3.75. Will this become too much? Spacing will become 1.25. So let's try. If I add 2, then of course it will become very 1.6 and 3.3. This is better. I will add 2 nodes. Distance between each node will be 1.67 meter. So this is better. 1.25 was too close. So this is good. So let's press OK. So in this way, I will choose right now. Let's do Control Z. I will choose all the rafters and beam tool, insert node, add endpoints. How many points we saw right now? 2 points, and click OK. So for all the members which I had selected, 2 points have been created. So I'll copy this. I'll choose one of the purlin, geometry, copy, paste, and reference point. And this point I will choose as a reference. Okay, and then click over here, enter. Click here, enter, enter. Yes. So purlins have also been modeled. The next part what we need to model is the bracings. So bracings, okay, let us check the spacing between purlins. If I double click on any of the purlin, any of the spacing between purlin, 1.67517. So that is the reason here I have written 1.675. Okay, so purlins is also done. Now the next part what we want to model is the bracing. First let me model it, then I will be explaining you the structural reason for all of them. Okay, so for bracing, simple. Bracing I will model at both the ends of the structure. So here from bottom to top, cross bracings from bottom to top. From this point, these are the plan bracings till here, from here to here. Similarly, okay, these are columns bracing and these are plan bracing. I have chosen all the bracing. I will just mirror them. So mirror them. We have seen mirror YZ plane. Node will be this one. Create a copy. Click OK. So the copy has been created. So press Ctrl and again choose them. Okay. Now I want to copy this at the end as well. So again copy, paste, reference point. This is the reference point. Okay, so I'll copy out over here, and okay, so the copy has been created. So I have also modeled the rafters. Guts I'm not modeling right now. Okay, I will explain you the reason. So I have completed my modeling. Let us understand the structural reason, the understanding for this framing, what we have done. The main purpose of steel structure, the main purpose of the steel element is to transfer the load, what would be coming on your structure to the ground and to protect whatever will be there inside your structure, right? So the client and architect have decided that this would be there. They have decided the plan area, that they want a plan area of some height of my structure will be 5.5 meter. This will be the inclined roof. This will be the other inclined roof, and again 5.5 meter. And 5.5 meter inclined roof, inclined roof, and 5.5 meter. And connect them. Let's connect the top part. Okay. So this is the. Let me bring this to the center properly. So this is the part what the this is the structure what they want to model. Okay, but you know this framing, you cannot have one long beam of 19 meter, you will need multiple supports. So you have to decide as a structural engineer how many supports you have to give in the middle so that this area can be satisfied. So as a thumb rule, spacing between column you generally keep between 3 meter to 5 meter. Larger the spacing between the columns, heavier will be your the frame. So this is your one, this one is your portal frame. So if you see, this single part is your portal frame, and this framing you there will be number of number of these frames. So you have to create number of copies of this frame along the length of the member. So if the spacing between your frames will be more, then this frame will become heavier. So what I have decided, we want six number of spacing. So one, two, three, four, five, six. So we gave this kind of six spacings like this. Okay. Now this is okay, your portal frame spacing. But at the top again you have, here you have your cladding, you have your sheeting. Your cladding you cannot directly place on your rafters, because then your cladding will bend. The spacing for your cladding, the sheet what you will have, the sheet, this kind of sheet you have at the top, and this sheet if you just place on your rafters directly, then this sheet will just bend like this. This sheet will just bend like this because this sheet is not strong enough to be capable of taking the spanning of around 5 meters. Na? So what we do, we create another layer of secondary members. We create another layer of secondary members over here like this. These are called purlins. I'm modeling just few of them. So then when you have your sheeting on top of them, then it will just span between them like this. It could bend like this. So this spanning which we allow is around 1 to 2 meters. So right now I have 1.6 meter. This is called purlin. And what is the purpose of bracing? Right now, whatever force will come in this direction, sorry, whatever force will come, whatever gravity load you will have, whatever gravity load you will have, the load because of the self weight of your structure and load because of the sheeting and live load, people walking on this roof area while working. So that all will be transferred from the purlins to the rafters to the ground. That is fine. But when you have the wind direction forces like this, these forces will also be taken care by your main portal frame. This is your portal frame, and when you have this force coming on it, this portal frame will take care of that load. But when you have load coming from the other direction, this direction, what happens? Your portal frame is not that strong, it is weak in the other direction. It will just bend, it will just move like this. So that this force gets easily transferred to the ground, what we do, we model these kind of diagonal bracings. So when these diagonal bracings are modeled, the lateral force coming in this direction, they will just be transferred from the ground here like this. Similarly, we do at the end. In IS code, in our Indian code, it is recommended that at every 20 meter, at every 20-meter interval, you can have these bracings. Okay, so also you need the same for the plan. So this is the top area. Here also you have this kind of bracings, plan bracings, similarly over here, and in the ground as well, in the other side as well. So whatever force will come in this direction, in the blue direction, that will be transferred to the ground from diagonal bracings. So we understood the purpose of columns, rafter, purlin, bracing. These are the four important elements. One more thing. Now you also have covering, or you also have sheet which is connecting. Let me show you this by maybe uh, blue color. You have this sheeting over here, right? You have this sheeting at this top part. Okay, I'm just maybe doing few things like this. This load on this will be supported by your purlins, what we have modeled. Similarly, you also have this on the these walls, these columns. So they can also directly be supported by the columns, but if they are supported by the columns, because of the wind, they can bend in this way. Again, this bending is too much. So if you don't want them to bend in that way, we give additional girts. Again, spacing of these girts is around 1 to 2 meter like this. Okay, so these additional girts are given, then these girts will be connected to the column. If you see any section, if you see any section, let me show you this section. Here you have your rafter purlins. I am only drawing at one side, and here you have your girts, and in this way you will have your sheeting. And you can just rivet it like this. It will be riveted here. And these girts would be these purlins would be connected with this cleat angle. These all things we will see in connection, or here you can directly rivet it to the column. Here you can rivet this to the columns like this. So in this way your whole structure, and also you have bracings you have at this purlin level like this bracings. And also here the orange color are bracings. If you see from top view, if these are the purlins, you will see this kind of bracings what we have modeled. And this you will see like this. Okay, so I've shown you all the elements, and one more thing, yes, we also model. You also have your members over here like this. Why? Because this blue part, this sheetings, you also have at this side. If you have at this side, you also require support from this side. So you have your girds like this, and wherever you have your opening, at that point you can just cut it out. Wherever you have your opening, at that point you can cut it out. But in my modeling, okay, here I have also shown you purlins and girts. This part I am not modeling in my structure. The modeling of this part I am not doing. I am directly applying forces to the column, and this I will just give additionally in my drawings, or I will tell the client that he can mark them additionally. I am not considering them as structural part. I am not modeling them. So this is also possible. Some people also don't model the purlins, and also for the purlin design they do separately, and directly they apply whatever loading is coming on the rafter. So the important part, what they model is column, rafter. Purlin they don't model, but we will be modeling in our case. So purlin I will model, and bracings I will model. Guts we will not model in our structural model. We can directly give it in the drawings. Okay. So everyone tell me in the comment section, are things clear to you? Did you understand modeling? Kindly answer in the comment section. Tell me, am I audible to you? Were you in the session? Did you understand? Everyone kindly answer so that I will understand that all of you are with me. Should we proceed? Okay. So the simple part. So we have done the modeling. Now the next step before we go in properties, what we want to do is we want to give the grouping of the elements. So it is easier for us when we assign the properties. So what I will do, if you go in utilities you have the option group. Click on this option groups and let's create as group. We will create groups for column, and in style select type you will choose beam. Ramarjun, regarding 20-meter bracing, I will tell you the clause number later on. Okay, this clause number I will be sharing with you. Column, then after that we have rafter, then after that we have purlin, then we have bracing. We are modeling these four elements. Now let's assign for columns. It's simple.
Excuse me, sir. This for a type we have to give beam for everything beam only, or for rafter
Yes.
beam column also you have to give type beam only.
Yes, let me show you. If you click on create, if you see what are the various type which is available, either it is a node or a beam or a geometry or a floor. So in our case, all the members are beam, will be classified under beam. So for all the, okay, I've closed it. Yeah, for all the members you have to choose beam, whether it is a column, purlin. So beam in general it means it is a member. So all are your steel members. So you have to just choose beam for all of them.
Okay.
Okay. So select. Now if you want to, you have to assign. You can see it's written over here beam unassigned. So you have to assign the columns. So what you will do, if you go in select, you have various options to choose element. So in beams, you have this option parallel to Y. If you click parallel to Y, all the elements which are parallel to Y, that would be selected. And in my case, these all members are column. So I'll click on column and I'll say associate to selected geometry. Associate. Now it's written beam assigned. Similarly for rafters. For rafters, what I will be doing, view. I will first view in the front view, and I will choose all the top elements. And if I click on isometric view now, I will only see the top elements. I can right click and click on new view. If I right click and click on new view, I will get this option. I'll just click display the view in the active window. Click OK. So only that part will be visible to me. It is easier for me to select now. So I'll go again in plan view and I'll choose all the rafters like this. So these are all my rafters. Associate to selected geometry, associate. Next one is purlins. So for purlins, I can go select parallel to plate, beams parallel to Z. So all the purlins are selected. Associate to selected geometry, associate. Now I want to choose bracings. So for bracings, I have a simple method: view, display whole structure, select beams parallel to X, nothing, parallel to Y, parallel to Z. Okay, right click. Okay, not this. You have a other option, inverse. This was selected. If I click on inverse, apart from them, all others member would be selected. So right click, new view. Okay. So now view, go in plan view, and I can easily choose my bracings. So these all are my bracings. So bracings, associate to selected geometry, associate. So I have chosen all of them. Display whole structure. Now if you want to check, column, highlight, done. Rafter, highlight, done. Purlins, highlight, yeah. Bracing, highlight, okay. This is good. Now I can close them. I have created the groups. Tell me, it's clear to all of you? Should we move to the next step? Quickly, properties. We will go in properties, click on section database. In section database, now we will choose properties for all our members. Go in Indian. Initially, we can roughly assign any property. So right now, first we will start with columns. So I want a bigger size of column. So I'll drag this down. Maybe ISMB 600. I will double click on this. This I want to assign for my columns. For my rafters, I will go for ISMB 450. For my purlins, I want channel section. So I'll go in channel ISMC 150. And for my cross bracings, I will go with pipes. And I will take a smaller, maybe smaller pipe, 42 dia pipe, medium, double click. So I have modeled all the elements. I mean, I have added all the elements. I can just close. Now let us understand why I have chosen these elements. See, in general, if you want to model a column, for column, either you can take I sections or you can take tube sections, or you can go for these are the best two sections which you can take. Sometimes people also go for circular sections, and people can also go for maybe back to back double channel sections, or they can go front to front channel sections in this way. So multiple options are available, but the most suitable option is the I section. So that is why I've chosen this I section. I will be explaining you all these built up sections later on. Right now we will focus only on this. For rafter, also all these possible things are there. Right now I have again went for I section. Then you have purlins. In purlins, you have two options. You generally we do not have I section for purlins. We go for channel sections. So channel sections are generally used for purlins. Or if you have cold form members, then you go for Z purlins like this. This is cold form member. This is some separate kind of member. This also I will be explaining you later on. This is cold formed steel. This we will understand later on. Right now we are doing with purlins, normal channel purlins. And for bracings, either you can have angle sections, or you can have channel sections, or you can have tube sections, or you can have pipe sections. Any of the things are possible. So right now I went for pipe. I think angle also would be better. You can also go for angle sections, or you can have double angles like this. This is also a good possibility. Okay, so this also we will see. Let us assign them. Now we have just added them. We need to assign them. To assign them, I have one simple method. I can go in view, no, select. I will go in select groups. If I click on groups over here, I will get all the groups what I have created. First ISMB 600. Let's assign to column. Assign. Yes. Next ISMB 450. Let us assign to rafter. Assign to selected beam. Assign. Yes. Next ISMC 150 for my purlins. Assign to selected beam. Assign. Yes. Finally, pipe section for my bracings. Assign. Yes. So we have assigned all the members. I can close this. Now, if you want to see this, how it will be looking, go in geometry or go in view. In view, you have this option 3D rendering. Click on 3D rendering and this 3D rendered image would be created. Let's look this properly. This is your element. You can zoom and check it in detail as well. Now we have certain problems. I see some problems over here. First of all, this column orientation is not correct. Let me explain you the reason for that. Okay, so now let's see, or maybe let's wait. This is my model. Right now you can see this main portal frame. Let me mark it with some color. This frame, this is my main portal frame. If you see, it is like this. Okay, and if you see from top view, you have this I section, then you have these rafters, and again you have this I section. But this also we want in similar way. This orientation, right now this I section was like this. This I section I want in this way. So whenever whatever force is coming on this, it will be subjected to major direction. So when you have I section like this, when this force is coming on this, it will act in a good way. Similarly, when I have this I section in this way, and when force is coming from the other direction, this would be the better orientation. For this orientation, minor direction orientation, when wind is coming like this will become weaker. It is not that strong, and this is stronger. So this is the correct, and this is wrong. For that reason, let us change the orientation of few members. So click on geometry. To change the orientation, you need to go in properties. Here you have beta angle. Click on beta angle, create beta angle, right? 90 degree. Okay. This you need to assign to these members. So what I will do, view, front view, and choose these three members and assign to selected beam. Assign, yes. Now they will be rotated by 90 degree. Let's see 3D rendering. Now you can see they are rotated by 90 degree. This is correct. Next problem what I am facing is, if I zoom over here, you can see, yes, you can see my rafter is inclined, but my purlin is straight. Purlin should be inclined. Right now, what has happened? If you see, this is my rafter, which is inclined, but my purlin is modeled in this way. Correct? But I want this purlin to be modeled like this. And also, I don't want it to be modeled here. I want it to be modeled at this top. Correct? So first from this we will convert into this, and from this we will move it to the top. So from this to convert into this, we need to rotate it. By what angle we need to rotate it? Whatever is the angle of my rafter, that same angle will be this angle, right? So what is this rafter angle? The rafter angle is given in my Excel, and you can see the degree is automatically coming over here based on the height and roof height. 11.48. So this angle I want 11.48. So beta, create angle 11.48, and also another minus 11.48 for the other side. For the other side, there I want to rotate that in the other direction. Whatever I have over here, whatever I have over here, these are like this. I want in this way. Right now they are like this. So I want to rotate in other direction. So I am giving minus 11.48. Okay. So these two we will be assigning. So for that, select group, purlin, right click, new view. Okay. And let's view this from top. So these are the left side purlins. So for them it is 11.48. Sorry, left side purlins 11.48, assign to selected beam, assign, yes. Right side purlins minus 11.48. Yes, this orientation I will be explaining you, Tushar. Okay, so left and right is done. I'll explain you shortly. This orientation also we have given. Now let's see 3D rendering. Now if you zoom, they are properly rotated. And here also they are properly rotated. Right? So this is correct. This looks good. Now I want to shift this upwards. So shifting this upwards, let's see how I can shift them. See, right now, this distance is 450 because I have assigned ISMB 450, and this distance is 150 because I have assigned ISMC 150. Modeling is done from this node. I want to shift from this node to this node. Right, let's draw this exactly above this so it is easier. I want to shift it over here. So from this node, I want to shift to this node. So what I will do, this is the distance 225, and this is the distance 75. This is the distance which I want to shift it. This is 150, right? So 225 plus 75, I want to shift this by 300 upward. So how I will be doing that? Properties is there, material is steel. That you need to do in specification. If you go in specification, beams, first tell me is the beta angle clear to all of you so that I will move towards the next step. Everyone tell me, is this beta angle clear to all of you? Should we move to the next step? Did you understand how we rotated the purlins? The reason why we rotated it, I will explain you shortly. But first tell me, did you understand how we rotated it? Yes. Now go in beam. In beam, you have these various options. Second option is offset. Offset, you can choose local. And local axis, what are the local axis of the member? If you see, uh, if this is my member right now. This is z axis, this is x axis, and vertically upward is my y axis. We have discussed this. I want to shift it in local y axis upward by, y should be 300 mm, right? So I will go in offset, start, y will be 0.3, add, again beam, offset, let's choose local, y, ending point y 0.3, add. Let me test this on one of the purlin. This purlin I will, or let's do everything together. Select group purlins. Let us assign them. Assign to selected beam. Assign. Yes. Ending. Assign to selected beam. Assign. Yes. So let's check it out. Close. View. 3D rendering. Zoom. Zoom. Yes, you can see they have shifted now. Now it looks proper. Now it looks proper. Is everyone convinced? Yes. Okay, now we have given the offset. One more thing. Let us understand the concept of release. Generally, when you have beams like this, and you have connected with these nodes, by default STAAD will assume that these are fixed connections. And whenever bending moment diagram, whenever you try, okay, this kind of structure is there, and whenever you try to create bending moment diagram, you will get bending moment diagram in this way. Here, because it is fixed support, you will get some bending moment, and it will reduce like this. This is by default bending moment diagram in STAAD.PRO. for any members. But for purlins, we do not want like this. Why, I will explain you shortly. These are the columns. The black color, the top beam is the purlin. In purlin, we expect the bending moment diagram to be like this. This is bending moment diagram. Why? Because my purlins are simply supported. They are not fixed supports. Why I am telling that? If you see, this is my rafter and this is my purlin. This purlin, I am connecting only with the web. And how I am connecting? I am having my cleat angle. This is my cleat angle, and cleat angle is connected with the web like this. So the connection with my rafter of the purlin is only through this bolt, which is web connection. So because it is a web connection, it is a shear connection, and because it is a shear connection, I don't want my moment to be transferred to the purlins. So I want them to be simply supported. For this reason, you need to give releases to your member. So how to give release? Specification, beam, release, start. We will release all the moment mx, my, mz. Add. Same thing we will release for the ending part mx, my, mz. Add. Now we will assign them. Select, group, purlin, assign, yes, ending, assign, yes. I hope you understood what is release. Because I have given release, this will not transfer my moment to the rafter. Whatever force is coming on this will only be transferred to will be acting as a simply support case. I hope you all of you are understanding what is the meaning of release. Moment we are releasing at those nodes. Okay. Again, when we discuss connection, these things will be much clearer. Next important thing what we want to discuss is the bracings. In specification, for bracings, we will be assigning tension member. I will choose tension and add member tension. So I'll select group bracing. All my bracings I will be assigning member tension property. That means these bracings will only carry tension force and they will not carry any compression force. Now this is again a complex topic. Let us understand. Member tension. See, now I am showing you. This is my column. This is my another column, and these columns we have connected with bracings. Okay, here you have maybe purlin. When you have this load coming over here, because of this load, this column will be under compression and the other column will be under tension. Is this clear to all of you? Now I will be telling you few things. You have to tell me, are these things clear to all of you? Everyone, always keep writing in the comment and tell me, are these points clear to you? Because of the wind force coming over here, one side of the column will be under tension, under compression, and the other will be under tension. Why? This will try to become like this, right? This will try to become like this. This column is becoming shorter. That is why it is getting under 10 compression, and the other column is becoming longer. That is why it is becoming like tension. And what I am assigning to these members only member tension property. That means I am telling Whenever these, now okay, let's see another thing. What will happen in reality? Because of the force, because of this force, yes, Tushar, I will answer your question. Let's first discuss bracing. Because of this force, what will happen? This will buckle like this. It will buckle and this will get elongated. Because this is buckling, this will just become inactive. Already it has buckled. If you have some member, if you have something, and if one of your member, if your member is buckling, if your member is bending, that means that member is not contributing to any strength. It is just buckling. It is similar to maybe it is failing and it is not contributing to any strength. Because this member is buckling, this member is just becoming inactive. It is not transferring any force to the ground. And the only member which is active is this member which is under tension. This member which is under compression, this is not working properly because it is getting buckled. Similarly, when you have forces coming on the other direction, when you have force coming from the other direction, initially the member which was under tension, that will become compression, and the member which was under compression, that will become tension. So this will become compression, this will become tension. Also, the member which is under compression, that will just buckle out. This will just buckle. This will just bend, and the member which is under tension, that will only be active. So what we do for all the bracings, we assign member tension property. We tell STAAD.PRO that when this member is under compression, just consider that member as inactive and do not design it. Only design the member when it is under tension. What happens if okay, we all had understood studied in our first session that steel is good in tension. Let me give you a simple example. Imagine this is a rod which is fixed on ground. If you are pulling this rod, it will not easily fail. It will not easily break. But on the same case, if you are having this same rod, and now if you are pushing this can easily fail, but this will not easily fail because it will take more force in tension. It will take less force in compression. Steel is good in tension. It is not good in compression. So what we do now, this part, this is our structure. Let's do in black. This is my rafter. This is my purlin column. And these are my bracings. In first case, I have given this member tension property. Here I have assigned. And in second case, I am not assigning that property. I am telling I will not assign such property. Let STAAD.PRO design it for whatever force it is getting. And here I have applied some force in both the cases. In first case, the blue color member, maybe they are having a dia of 40 mm. This tube is carrying a force of 40 mm. Because I have assigned member tension, this is just becoming, this is becoming inactive. It will not, STAAD.PRO will not design this member, it will only design the other member, and 40 mm is working, it is correct. But here, because this member is also trying to buckle, this member is also becoming in tension. Here I have not given the member tension property. both the members are active, because this is active and it is getting compressed, here I will need maybe 100 member. Only then this will work, otherwise it will not work. For 100 it is not buckling. And here even 40 is fine, because when this is buckling, I'm just telling do not consider this member. So in reality what is happening, in reality, this is my member, this is my force, only this member is considered for designing, this member is not considered, and this member is just buckling and it is not contributing to any strength. And similarly, when force is coming from the other side, only this member is considered. So this is economical in design, this is good in design. I'm getting lesser specification, lesser size of my member, and it is economical. And this is becoming very uneconomical, very rigid, and there is no use of having such heavy members as my bracing. Is this concept clear to you? Everyone, please answer and tell me if this is clear to you. 99% of the engineers don't know this, why we are assigning member tension property to our bracings. They just assign it because this is the standard way in which it is done. But the reason, most of them are not clear. I have explained you. I hope you have understood why we are assigning this member tension property. Now let's answer the question of Tushar. Okay, what we did, one more thing. This is my rafter. This is my purlin. And for purlin, I have given this orientation. Because I have given this orientation, now when I apply force on this member, I will apply force in this direction. Right? Many of you have studied. If you have this bracing, if you have this rafter, wind load will be in which direction? It would be like this. It would be like this. It would be like this. And maybe like this. So what we understand from this, that for rafters, inclined force is acting. This force is perpendicular to the force of the local axis, force of my local y-axis, yz. Na? So it is parallel to y-axis. So for this reason, for modeling, if I just keep the modeling in this way, local y-axis is upward. So it will model, the force will be modeled like this. Means the force would be modeled. Let's show this in blue color, which is, it would be modeled like this. So this is wrong. The blue, so blue color what I have shown, this is wrong, and the red color is the right thing. So for that, I need to give the member orientation for my purlins. If I don't give member orientation for my purlins, the results will not be correct. It will be wrong. So member orientation for purlins is compulsory. You need to give. If you don't give, you will get wrong answers. Tushar, is it clear to you?
Yeah, one small question, sir. Just can you explain
Yes.
me that shifting of purlins? I lost my internet that time.
The offset.
300 to shifting in STAAD.PRO. How to that command?
Okay. How to give the command. Okay. Did you understand the value, how we got this 300?
Yeah, how to give the command to shift that?
Okay. I hope this
Yeah,
picture is clear to all of you. Why we are giving, yes, let me explain to others why we are giving 300. I hope this is clear to everyone. Now let's understand. Can you mute yourself? Just a minute. I will. Okay. So how to give the command? You can go in beam for the offset command. Go in offset. Here you can choose the value. In y direction, I want to shift by 300 mm, so I'll type 0.3, and direction will be local because I want to shift it in local y direction upward, and I will give the value. Same thing I will do for location start and location end. Shravan, is it clear what we are doing? Local start and local end.
Where is the local start? Can you just say again? Show me again, please.
Beam, offset in y
Beam.
direction 0.3,
Yeah.
and direction from global you will choose local.
Okay.
Okay. Why we are choosing local? Because we want to shift it in local upward direction. If I choose global, it will move like this. It will move vertically upward. If I choose directly global axis, still it will be correct, but it will move like this. Maybe you will get somewhere over here. So I don't want that. I want exactly above my point. So I'm choosing local.
You said start and end. Where is that start and end in the?
Start and end. Okay. See, this is my purlin which we are modeling,
In
and
the
for
STAAD
each
Pro, no, in the STAAD Pro, I'm asking to give command that start and end.
beam,
Yes, sir.
offset, location start is there. Here you will
Okay.
write 0.3, choose
Okay.
local, and add it. Again, next time you will add and start,
Oh,
end, 0.3,
so
local, add.
first
So same thing.
select all purlins, then do one by one purlin or all purlins
No,
at
no,
a time.
all Perlin at once. First you add this property. First I will add this one, like start local, this and end local. Then
Okay.
when I want to assign this, I will go and select group
Like
Perlin.
release
I'll
of
choose all the
like
Perlin. Right.
wind releases. The
Yes,
same
yes.
way.
I will choose all the Perlins and assign local. These two properties. Same like release, start and end.
Okay.
But the next important thing, what I am telling, this, like I told you, member orientation for Perlin is compulsory. Otherwise, you will get wrong answers. Member orientation you need to give. But this offset is not compulsory. Even if you don't give the offset value, you will still get the correct answer. So offset is not it is not important in STAAD.PRO. Even if you don't give the offset, you will still get the same answer and correct answer. So generally, this offset we don't give. I will tell you the reason behind it. This is my rafter. Shravan, you can unmute. You can mute yourself
Sorry.
after asking the question. So this is my rafter, and this is my purlin, which I have rotated. Now, even if I don't shift this upward over here, like I want to shift it over here. Even if I don't shift over here, still I will get the same answers because load will be applied over here. Either it is applied over here or here, the answer will be same. So it is not necessary to give the offset command in STAAD.PRO. I am just showing you that offset command so that you understand how you need to give it. But analysis wise, result wise, STAAD.PRO is only doing analysis from node to node. So anyways, even if you shift your node by 300 mm, you will not get any big difference in your results. So offset is not important, and from next session onwards, we will not be assigning offset in our practical models because this is just waste of time and it will not affect your results. But orientation is important. Orientation we will be giving, but offset we will not be assigning. The member offset, what you understood right now, this huge process, it is important for you to understand how you to do, but we will not be doing this because this will not affect my result. I hope this is clear to all of you. I hope this is clear to all of you. Yes,
One more question, sir. Kiran here, Kiran Moile.
yes, yes,
We are not modeling girls here, na? So
yes.
it will beneficial, na, to reduce portal sections, column sections by modeling girls.
Uh, it will it will not be that effective. Maybe slightly. If you model guts, the forces which will be coming on your column, that would be maybe slightly lesser because of the stiffness of overall structure, and it
We
could
can
be
reduce na
slightly
slenderness
economical.
of column. Yes,
Yeah,
yes.
the slenderness of your column could slightly reduce, but still it is avoidable. What we do, the purlins and the guts, they are considered as secondary members.
Okay.
And if sudden failure has to happen in your structure, even if your girts are not working and they fail, even if they bend or they fail, then the whole
Hmm.
force will directly come on your columns, and in that case we don't want your columns to become weaker. So in general, the columns and rafters are modeled as primary members and they are stronger. So even if your purlins and girts fail, your column and rafter should not fail. So you should
Yes,
not
yes.
consider the stiffness of purlins and girts in your main structure. So your main portal frame should be designed in such a way that even if you don't have your girts, they are still capable of carrying that force. So
Okay, okay.
if you model girts, the slenderness of your column, the stiffness of your column will increase and it will be beneficial, but it is better that we not model it.
Yes, yes. In some cases,
And
modifications happen on site. For opening, they
hmm,
can remove. So
yes,
we don't
it
consider.
is
Okay.
better we don't consider that in
Yes,
our
yes.
structural strength. Even if you
Okay.
don't consider, even if you consider it, there will be very less difference in the values, but it is better that we don't consider it.
Okay. Okay.
Okay, so these points are clear to you. We also wanted to model the same element. Now we what we do, yes. Next thing, tomorrow what we will be doing, instead of rafter, we will be modeling truss. This kind of truss we will be modeling instead of your rafter. Okay, today is Friday, so we will meet on Monday. On Monday, I will be showing you how you can model truss in place of rafter. And Ramarjun, regarding the 20 meter clause, let me quickly check, but maybe I'll need time to give you a proper clause, but let me just quickly check it. This is the code. Just a minute. See here it's written uh, if more than one bay of longitudinal bracing is provided near the center of the building section, the maximum center line distance between the two lines of bracing may be restricted to 50 meters. Sorry, it's 50, not 20, for covered building and 30 meter for open gantries. And the maximum distance between the center of the bracing to the nearest expansion joint of a building or section may be restricted to 90 meter. The maximum length of the building may be restricted to 230 meter for covered building, length of the building section. So here you can see it is mentioned that bracings may be restricted to 50 meter, but this is the maximum. We generally advise that 20 meter would be fine, because in the second line again it says 30 meter for open gantries. So here it's saying 50 meters, but I think for practical purposes 20 meter is good enough. Is this okay, Ramarjun? We have this clause number 3.10.3.2. It's written 50, but yeah, we can either go with 50 or better to 20 or just end to end of your members. Okay. So again, today I am short of what I wanted to complete. This is what we did. Pitched roof warehouse. This we have modeled. I also wanted to model this with a truss, and this is what you would be seeing. This we will see on Monday. And yeah, let's continue on Monday. I will be showing you this rafter and truss, and we also will see on Monday regarding the monoslope roof. So on Monday we will be seeing few things. One is with pitched roof with truss, and I will be showing you monoslope roof. What is monoslope roof? Pitch roof is roof where you have slope on two directions, and monoslope roof is roof where you have slope in one direction. This kind of structure. Okay, so let's discuss all these points on Monday. Then next week would be very interesting week, because we will be starting with application of loading. Loading is the most important part of the analysis of your structure. So loading part we will be starting from Monday. On Monday we will be doing the modeling for truss and monoslope roof, and then we will be starting with application of load: dead load, live load, wind load, earthquake load, crane load, and its combinations. So thank you everyone. Let's meet on Monday.